Module 9 shows how to perform a fatigue analysis using the fatigue wizard found in the results section. The fatigue analysis is based on stress information and a static stress analysis of the cantilever beam used in previous modules has already been performed. The beam was subjected to a 6-pound load at its free end in the negative y direction. The fatigue wizard is located in the analysis section. We must select analysis and then fatigue analysis. It will take just a few seconds for the fatigue wizard to load. The fatigue wizard will walk us through the 7 steps needed to perform a fatigue analysis. At each step, data is entered that is specific to the type of fatigue analysis being performed. In step 1, we must specify whether we want to determine the fatigue life using the strain life or the stress life approach. The endurance limit for 6061 T6 aluminum is 14 KSI and its yield strength is approximately 40 KSI. Our peak stresses are approximately 30 KSI, which is significantly higher than the endurance limit and relatively close to the yield strength. Therefore, we expect a relatively few number of cycles to failure, and we will select the strain life approach. In step 2, we have the option of updating material property data. We will use the default values contained in the Autodesk Simulation Multiphysics library. We must enter Poisson's ratio, which is approximately 0.3. We are not analyzing steel, so we must unclick the My Material is Steel box. If we want to edit the strain life constants, we can do so by selecting the Select the Advanced button. We will use approximate data computed by Autodesk Simulation Multiphysics. In step 3, we can specify a stress concentration factor if needed. We do not have any geometry changes, so we don't have any stress concentrations. Therefore, we will use the default fatigue stress concentration factor of 1. We will assume that the surface of our beam has been machined, and we'll click the Surface Modifier box. We will select a machine surface from the options, which gives us a surface reduction factor of 0.805. In step 4, we define a load multiplier curve that shows how the load varies with time. Time is not important to the analysis, but it is used as a parameter to define how the load varies during a cycle. We will use a cycle time of 1 second. Our load will start at 0 and increase to 100% at half of the cycle and return to 0% at the end of the cycle. To define a load curve, we must click on the Load Curve box. We will need 3 different rows to define the load curve, so we will right-click, Insert a Row, right-click, Insert a Row. At time 0, our load multiplier will have a value of 0. At half of the cycle time, which is 0.5 seconds, our load multiplier will increase to 1 or 100%. At time equal to 1 second, which is at the end of the cycle, our multiplier will return to 0. Note that we have a plot automatically created that shows the multiplier as a function of time, in our case ranging for a cycle from 0 to 1 second. In step 5, we define the type of information we would like to obtain from the fatigue calculations. We can get a safety factor or the life and cycles to failure. In this example, we will select cycles to failure. We must also define an expected cycles to failure or fatigue life. In this case, we will put in a value of 100,000 cycles. This number is not used in the calculations, but is used as a reference. In step 6, we can submit the fatigue analysis. It will take just a few seconds for the analysis to complete. In step 7, then we finally get our fatigue analysis results. We specified a desired number of cycles of 100,000. The predicted number of cycles to failure is 71,000. This is less than our specified number, so our design is considered to be unsafe based on these parameters. Note that we have a table that gives several numbers as a function of node number. Each column contains a different estimate for including mean stress effects. The first column, there is no mean stress effect included in the fatigue calculations. The next two columns give two different methods found in the literature. The last column gives the most conservative estimate for including mean stress effects and is the basis for the 71,000 cycles to failure. These numbers are log 10 of fatigue life. To get the actual fatigue life, we take the number 10 and raise it to this power. This concludes this video.